Hello everyone, welcome back to my channel. My name is Piyush and this is video number 10 in the series CKA 2024. And in this video, we'll be looking into namespaces, why are they needed, and we'll do a small task of showing the connectivity between multiple services when they are running in same spaces with respect to different namespaces. So we'll be doing a lot of hands-on in this video as well. Without wasting any time, let's start the video. But before that, please try to complete the comment target and likes target for this video. So the comment target of this video is 150 comments and the likes target is 250 likes in the next 24 hours. And let's start the video now. Alright, so let's start a little about namespaces. What exactly are these and why it is needed? So basically, it's just provides you another layer of isolation within your cluster so that you can separate your objects and resources within a cluster using different methods. Like, for example, when you create any resource and when you don't specify the namespace name, it by default gets created in a default namespace, right? So this is your default namespace. So when we were not specifying anything, like till now, we were creating anything in the default namespace. So that's what it is, default namespace. And when you provision a Kubernetes cluster, Kubernetes itself create a few namespaces by itself. For example, it creates a namespace called kube system, and all the Kubernetes components like the control plane components will be by default created in the kube system namespace. That is why it is important that we keep these namespaces separate so that no one can accidentally delete or modify any resources inside a different namespace. For example, I have three namespaces and I wanted to delete or modify a pod in the first namespace and I accidentally did that in the second one, right? So now it is easier to manage that because we have to specify which namespace we want to make the change to, right? But if we don't, everything resides inside one single namespace, then it is easier to make that mistake. So it helps avoiding that. Plus, you can assign different permissions and different RBACs to each of the namespaces, and your services, your pods resides in, another object resides in one of those namespaces. So there are different methods through which you can define your namespace names. For example, the one is Kubernetes. So let's say for the kube system, so you have your control plane components run inside this kube system namespace. And let's say you create a few more namespace, one for your test environment. This is your test environment. And then you create one for your prod environment. So here as well, you are keeping them separate with each other so that again, for the access level, for the better security, for the isolation, and so that they actually resides in a separate space, and it is basically for the isolation. Now, these resources within the namespace can access each other. Like let's say there is an Nginx pod over here and we have a Redis pod over here. So these resources, these pods within the namespace can easily interact with each other with their host name. Host name is Nginx for this, let's say Redis is for this. So they can easily interact with each other. But let's say you have the similar pod in another namespace in, let's say, the test namespace. So now if your Nginx pod has to communicate with the Redis pod inside the test cluster, they cannot directly communicate with their host name. They have to use something called as an FQDN or fully qualified domain name. So we'll show you how we can do that. We'll show that in just a few minutes. But before that, I just wanted to give you a gist of it. What exactly is namespace and why do we use it? Now I have opened two terminal windows and I have splitted my screen so that I can show you side by side of the difference between both the namespaces that we're going to create. So that is why it's there. So let's start with creating a namespace first. Or before that, let me show you the default namespaces that a Kubernetes cluster comes with. So if we run the command kubectl get namespaces, I'm using the alias k for kubectl, which I have already set it my bash profile. So it should return the namespaces. So you see, we have different namespaces. The first one is default namespace. So whatever resource we create without specifying any namespace, it will go in the default namespaces. So whatever resources we created till now, it by default had created in the default namespace. Then we have these namespaces. These namespaces are used by Kubernetes for its own purpose. Like for kube system namespace, we create all the control plane components inside this. So if we want to check what's inside these namespaces, we use the command such as kubectl get, let's say, get all hyphen hyphen namespace and namespace name kube system. Okay. So if we hit enter, we have these many pods running. So let's see, not just pod, other services and everything. So we have core DNS, which is again a control plane component. We have HCD, a control plane component. This is kind for networking. API server, controller manager, kube proxy, kube scheduler. These all are control plane components that get created inside the kube system namespace. Then we have a kube DNS service. So kube DNS service is responsible for resolving your IPs to the host name within the cluster. It will look into that. And then we have daemon sets, we have deployment, which is core DNS, like we have seen the pod as well, and then a replica set. So these are all the components inside the kube system namespace. So if we clear the screen and instead of hyphen hyphen namespace and instead of giving this big command, we can also use a smaller version of it, which is hyphen n. Single hyphen, not double hyphen, hyphen n, and then the name of the namespace. And it will give you the same results. So it's one and the same thing, right? Let's see what else do we have in other namespaces. So I'll replace kube system with kube public. Okay, there is nothing as of now. And then we have kube node lease. Okay, nothing in that as well. And local path storage, we have not created anything. So it's fine now for now. And if you want to check what's there in the default namespace, we can either specify hyphen n equal to default. Okay, or we can just remove this flag because by default, it will get the information from the default namespace. So it's showing the same results with hyphen n equal to default or without that. So currently we only have one service, which is cluster IP, which is automatically gets created with the cluster itself. So we don't have anything running at the moment. So again, there are multiple ways of creating a namespace because this is one of the Kubernetes object. Okay, so I'm going to create a new namespace ns.yaml, as there are multiple ways of creating the namespace, imperative way, declarative way. So we'll go ahead with the declarative way first. So I'll open this file in a vi, and again I'll enter API version, which is v1. Kind is namespace, should be with capital N. We have metadata. Side metadata, we have its name. So let's give this namespace a name. Let's call it demo. Okay, and that's it. We don't have to specify spec in that. Just these three fields should be sufficient. So we just have to provide the API version, name, and a kind, which is namespace. So now let's apply this YAML -app ns.yaml. It says API version. Oh, because I actually did not take care of this V. It has to be capital V. Now it should be fine. Okay, it says namespace created. So now if we do kubectl get namespaces or k get ns, one and the same thing, it will now show you the demo namespace that we have just created. So we'll mostly work on two namespace. For this particular demo, we'll work on two namespace. One is demo, another one is default. So that's why I have two separate terminal windows so that I can open one namespace in one and another one on second. So just to avoid any confusion. There is this, and if we have to delete the namespace, so kubectl delete ns and then space name or slash name demo. Okay, it's been deleted. Now, why I deleted it? Because I wanted to show you how we can create it imperative way. That is pretty simple, straightforward. Kubectl create ns or namespace and then name, and that's it. With just writing the 4 words, we can create a namespace. So that's why I was saying earlier that sometimes running a small imperative command is faster than running the declarative command where you have to create a YAML first and then create the object out of it. So sometimes this comes very handy. Now we have created the demo namespace. What we have to do to create resources inside this namespace? So let's see, we have to create a pod or a deployment. So kubectl create deploy. Let's give it the name nginx hyphen demo, and image is nginx. Okay. And then we have to specify the namespace name as well. So hyphen n space demo or hyphen hyphen namespace equal to demo. Otherwise, this will create the deployment in the default namespace. So if I hit enter now, image name, I guess. Okay, let's see. Ctl create deploy hyphen hyphen help. Kubectl create deployment and then deployment name and then hyphen hyphen image. So this should be okay. So I'll just remove the slash. Okay, it says deployment created. Now if we do get deploy, we will not see anything because this is the result from the default namespace. But if I want to fetch the resources from the demo namespace, I again have to add hyphen n demo. So if we have to get the resources from default namespace, you just don't specify the namespace, but every time you have to interact with a particular namespace, like whether you are getting any resources from that or you are adding or deleting any resources from that, you have to specify the namespace name like we did over here. So now we have 3 deployments running, 3 pods running in the default in the demo namespace. Now let's create one in the default namespace. So on the right side, I will create resources in the default namespace. So let's use the similar command, create deploy nginx test. And to remember over here as well, you can use the same name. You can create the object with the same name in multiple namespaces because they are isolated. So you can create an nginx deployment in demo namespace and the same name nginx you can use in the test namespace as well, or the default namespace. It will work without any issues. So create kubectl create deploy nginx test hyphen hyphen image equal to nginx, and then if you don't specify the namespace, it will by default will create it in the default namespace. So let's keep it that way and get deploy. Okay, so now we have nginx test in the default and nginx demo in the demo namespace. Okay, the next part is we have to see if the pods in this namespace on the left is able to reach the pod on the this namespace on the right. Right. So with that, we have to exec into the pod. If we do k get pods at both the places, k get pods, right? There is one pod running. So let's go inside that. K exec it, and then the name of the pod hyphen hyphen, and then space command, which is sh. So we are inside the pod on the test namespace. Oh no, see, I just made a mistake over here. I did kubectl get pod. So it is by default showing you the default namespace pod, right? So let's go and do edit. And now let me run the command again with namespace equal to demo. Okay, now k exec hyphen it and namespace. Then the namespace name again, hyphen n demo, and then hyphen hyphen sh. So now I am inside the pod in the demo namespace. On the right, we'll do the same, k exec hyphen it and the pod name hyphen hyphen space sh. Now over here, I'm inside the pod on the default namespace. Let's clear the screen on both the sides. Okay, before that I needed the IP, so I forgot that. Let me grab the IP from both the pods first. -o wide. This is how I will get the IP of the pod. And if I run k get pods -o wide, I will get the IP of this pod. So IP is 10.244.17 for the demo pod, 10.244.27 for the default pod. Okay, so on the left, let me run exec again. Okay, and on the right also I'll run exec again. So now I have the IP. So now let's try to see if this namespace is have the ability of reaching the pod from here to here and the other way around as well. So let's run a curl on this pod and let's see what does it return. It says welcome to Nginx. That is why it is getting the successful response back. You can run ping as well. By default, this is a lightweight Nginx image. It does not have ping installed. So you can install that binary and then you can run ping instead of curl. We just have to check the connectivity test. But over here, we are able to get the response back from the pod in the other namespace. Let's do the same over here on the right side. And now we'll be doing the curl on this pod. Okay, so let's do curl. Okay, we are getting the response on both the cases. Now let's try to do one more test. So I'm going to exit it from here and from the both the sides. And now I'm going to scale the deployment to 3 replicas. So kubectl scale -- replicas equal to 3 deploy nginx -demo, and the namespace was also demo. This should do it. And let's run the similar command here, kubectl scale -- replicas. This might see redundant work for you to type the command again, but the more you practice, the more it will be easier for you to in the exam and easier for you to work with Kubernetes. Because these all commands we use in our daily day-to-day work and a lot of times. So yes, this will be a good practice to do. So again, it was nginx test or default. I forgot what was the deployment name, but let's see. Yeah, I guess it was nginx text. So if we do kubectl get pods, we should have 3 pods running now with nginx test and get pods. So we have 3 pods running for the other as well. Now we will be exposing a service in front of this particular deployment on both the sides, because service is what we'll be using to access each other's pod. Right? So kubectl expose, this is an imperative way to create the service. Expose deployment. Deployment name is nginx demo. And on the port 80. And let's give this service a name as well. svc test. Oh, sorry, svc demo. Oh, I actually forgot to add the namespace name over here. So I'll do that afterwards. Okay. So svc demo is the service name, deploy port 80, and then I have to specify the namespace name -n equal to demo. But does it say there is no need to specify resource type as a separate argument? Okay, maybe I have to remove the deployment. Resource type. Let's have a look at the command. Kubernetes.io, and inside that we had a quick reference guide or the cheat sheet. Okay, let me search expose. Okay, so okay, so let's go back and let's make some changes to this command. It should be --name instead of this particular that we have used, and --name svc demo. Okay, it says it's exposed. So if we do k svc -namespace demo, so this is our service that we have just exposed on port 80, and the name is svc demo. Let's do the same on the default namespace as well. kubectl expose deployment, and the name of the deployment is nginx test, and hyphen name equal to svc underscore test, and hyphen port is 80. We don't have to specify namespace over here. So let's hit enter and exposed k get svc. Now, this namespace should have two services running. One is the default Kubernetes cluster IP service, another one that we have just created. And they both have different IP addresses. So 10.96.70.168 and 10.96.198.86. So they both have the different IP addresses and they both are in different namespace. Now, what we'll do now, we'll see whether we are able to access this service from the first pod or not, right? So kubectl get pods. Okay, let's not just get pods, -n demo. Okay, let's go inside this pod, kubectl exec -it and -sh. I'm inside the pod and it shows me that pod does not exist because I forgot to specify the namespace name -n space demo. Okay, now I'm inside the pod. Now let's try to do a curl on. Earlier we were able to reach IP from the pod, like from one namespace to another namespace. Now we want to check if we are able to access the service from one namespace to another namespace or not. Right. So let's use this name svc test, which is the service in default namespace, and let's do a curl on this service now. Says could not resolve hostname. Okay. Let's do the same test on the other namespace, k get pods, k exec -it, and let's pick any pod from one of the running pods, 5 and -sh. Okay, and the service name over here was svc demo, right? So let's do a curl on svc demo. Here also we have the same issue. So what we have got to know is we are able to reach the pods and services from the different namespaces with their IP addresses, but not from their host name. So what we can check is you can do a cat on etc resolve.conf. So this is the file responsible for doing the IP to DNS resolution internally within the cluster or within the host. So you can check this, and now you will see we have different host name that you can use. So if you have to access the service inside this namespace, so you have to follow this fully qualified domain name. And similarly, the pod inside the other namespace will have this file. So if you do cat etc resolve.conf, you will see a similar file. It's just the name is a little different. So it starts with demo, which is the namespace name, then service, and svc short for service, then cluster.local. And over here on the default namespace, the first string is default, which is the name of the namespace. So again, the same format, namespace name, service.cluster.local. So now let's see, when we were doing curl svc test, we were not able to resolve the host name. But if we do curl svc-test dot and then add this entire host name in front of that, like this. So now we are getting the reply. Now our pod in one namespace is able to get the response from the service in another namespace. And let's do this test from this particular pod as well on the default namespace. Curl svc demo dot default dot svc dot cluster dot local. I have made a mistake. Yeah, so instead of default it was the demo namespace. So svc demo dot svc dot cluster dot local. Okay, now we are getting the response back. So we have done the connectivity test. Now we know if we have to reach from one pod to another, we can definitely reach by their IP address, but IP addresses of pods are not static. So that's why we have used a service to expose the deployment or the pods inside the deployment to outside that particular namespace. And to access that, we cannot use the host name. We can use the fully qualified domain name. But if we were accessing the services inside the same namespace, we can use the direct name as the host name. So let's go back to this and let's see what we have done so far. So we have two namespaces. One is default, another one is demo. Inside that, we have a deployment with 3 pods and similar setup on the other side. And then we have exposed this deployment with the help of a service. Now, when we were accessing Nginx pod from one namespace to another, right, we were able to access with the IP address. That means IP address is cluster wide. The same IP address can be accessed from anywhere inside the cluster, even though they are as part of the different namespace. But when we were trying to access the service in another namespace from the pod in another namespace, like we were getting access denied because it was not able to resolve the host name. So that means over here we have to use fully qualified domain name. So this is as per the entry in etcresolve.conf, and it also shows that hostname are not cluster wide, they are namespace wide. So hostname, this SVC demo is specific to this particular namespace only. And SVC test, this service hostname is specific to this particular namespace only. That means if there was a pod inside this namespace, that pod can easily communicate with this service with their host name, because this particular host name is namespace wide, and similarly over here as well. So you can try to do this test by yourself as well. So the same way it will work over here as well, right? So this is what we saw. This is why namespaces are important. This is why we use namespaces. Okay, that's all about the namespaces in this video. I hope you have found the video helpful as always. So please try to complete the comments and likes target of this video in next 24 hours. And if you found the channel valuable and if you are new here, please consider subscribing it. Otherwise, I will see you soon anyways in the next video. In the next video, we'll be looking into multi-container pods and a few related concepts such as arguments, commands, and so on. So yeah, I hope you are having a good learning experience so far. So please keep on sharing your progress on LinkedIn, Twitter, and yeah, thank you so much for watching. I will see you with the next video.